normally distributed here are is the scores. Scores are normally distributed. So the scores are X. So when he says that the mean of 800, this means that X, the scores, and this is the mean of the scores, which is 800, okay? And the standard deviation is 50. So sigma is 50. Mu is 800. If the school only wants to admit the top 10% of students, look carefully to this condition. The school wants to admit the top 10% of students. Now, these are the scores of the students. The mean of the scores is 800. Where are the top 10% of the students? Well, the top 10% of students would be somewhere here. So this area is 10%. And his question is, what should the cutoff score for admittance be? So he's asking for a score. Scores are the random variable. So cutoff score, this is one of the values, one of the scores. So he's asking about x0. Which x0? The cutoff score that the school will take to admit the top 10% of students only. So what information do you know about x0? I know that probability that x is greater than x0 is 0.1, 10%. Or if you want, you can write probability that x less than x0 is 0.9. Both are correct. So the question, find x0 so that the probability of x greater than x0 is 0.1. That's actually this exercise. So to find x0, we mentioned last time that we change it to z0, and we find z0 from the table. But to find z0, I cannot deal with 0.1. I have to deal with this area. And this area is 0.5 minus 0.1, which is 0.4. So now I search for 0.4 in the table to find z0. So if you go to the table and search inside the table for 0.4, here I have 0.38, 0.40, so it is in this row, 0.4. .3962, the area is increasing, 3980, 3999, 3997, 0.4015. So is it in the middle between these two, or one of these two values is closer to 0.4? Of course, 0.3997 is closer to, this is the value I'll deal with, and the Z value would be 1.2, and if you go up 8, so Z0 is 1.28. So for the area 0.4, Z0 is 1.28. Now, once you have Z0, you can find X0 because there is a relation between Z0 and X0. We said that X0 is Z0 times sigma plus mu. So it's 1.28 times sigma, which is 50, plus mu, which is 800, and the answer would be 864. So this is the cut-off score for admittance. Which means that any student who got above 864 will be admitted to this school, and the percentage of those students is 10%. 10% of students scored above 864. Another question, a random variable is normally distributed with a mean 60, standard deviation as 9, so the mean is given. The standard deviation is given. What is the probability that a randomly selected value will be less than 46.5? This is a usual question. Change it to Z and solve it. What is the probability that a random value will be greater than 78? This is also a usual question. Change it to Z and solve it. What is the probability that a randomly selected value will be between 51 and 73.5? This is also a usual question. Change it to Z and solve it. Another exercise, a maker of cell phone batteries has determined that the time between the charges is normally distributed. So that's the variable, that's the random variable, the time. And as we know, it's a continuous random variable. And the standard deviation is given. What about the mean? The mean is not given. If a customer wants no more than 5% of the batteries to require charging in 13 hours or less, what must the mean time between charges be? So he is asking about the mean. What is the mean? The mean is unknown here. Okay. So sigma is known, sigma is 1.5, and the mean is unknown. What is the information in the question? This is the information. If a customer wants no more than 5% of the batteries, I'll draw a figure to try to understand this information. This is the time, x. I have the mean here. The mean of the time is mu, and it is unknown. If a customer wants no more than 5% of the batteries to require charging in 13 hours or less, 13 hours or less, this is a time. So 13 hours or less. So I need 13, probability of x, the time, require charging in 13 hours or less. So x is the time between charges, and it should be 13 or less when, if a customer wants no more than 5% required charging in 13 hours or less. So the probability of x less than or equal to 13 is not more than 5%. So it's the most, or the largest probability is 0.05. So x less than or equal, probability that x is less than or equal to 13 shouldn't exceed 0.05. This is what he means when he says if a customer wants no more than 5% of the batteries, so this is the probability of the batteries to require charging in 13 hours or less. So the area to the left of 13 is 0.05. So where would be 13? 13 is an x value. If the area to its left is 0.05, this means that 13 is a number here. It's a value of x. And the area to its right is 0.05. So I know this information. Now, how can I use this information to find the mean? Well, I need to change to z. So if I change this probability to z, then I have probability that z is less than 0 is 0.05. Z0 now is a number to the left of the mean. If you change this to z, then this is 0. Now I know the mean here. And this is Z0 I'm searching for. So it must be a negative number. Now this area is 0.05. I cannot use it to find Z0. I have to use this area. So I subtract 0.5 minus 0.05. The answer is 0.45. Now I go to the table and look for 0.45. And 0.45, this is for 4, this is for 5 more. So we go to 1.6. It's increasing. Here 0.4495, 0.4505. These two numbers, in fact, 0.45 is in the middle between them. So I take the number in the middle. So it's 1.6, and this is 4, and this is 5. So the number in the middle is 1.645. So Z0 is 1.645, but remember it's a negative number because it is to the left of 0. So now this is Z0. What about X0? We know that Z0 equals what? 13, which is X0, minus mu, which is unknown, over sigma, which is 1.5. So this equation has mu as an unknown. You solve it, and you find the value of mu. Cross multiplication, we get negative 2.4675. So mu would be, if you take mu to this side, bring this number to this side, it would be 13 plus this number, and the answer would be 15.4675. So this is the mean. So this is how we find the mean. Another question, a random variable is known to be normally distributed. This is mu, this is sigma. Determine the value of x, so we need x0, such that the probability of a value from this distribution exceeding x, so probability, let me sketch a graph. This is x. The probability of a value from this distribution exceeding x is at most 0.1. So the probability that the values are exceeding x0 means more than x0 is at most 0.1. So 0.1 is the largest area possible. So x0 has to be a number here to the right of the mean, because the values exceeding x0 is just 1% or 10%, sorry, 10%. So x is greater than x0 is 0.1. To find z0, you change it. To find x0, you need to change to z. And you cannot deal with 0.1, you have to deal with 0.4 here. So you look for 0.4. I think we have just looked in a previous question about 0.4. Yeah, 0.4 is here, 0.3997. So the z0 is 1.28. So z0 is 1.28. And you can use the relation x0 is 1.28 times sigma, which is 0.5, plus mu, which is 5.5. And we will have x0 equal to 6.14. So this is the value of x in which 10% of all x values exceed. Referring to your answer in part A, our answer is x0 is 6.14. What must the population mean be changed to? Okay, so mu would be changed to another mu, which is unknown, if the probability of exceeding the value of x, so probability that x is exceeding this value, 6.14, is reduced from 0.1 to 0.05. So the probability of x greater than x0 is not 0.1. It is reduced to 0.05. And we have x0 from part 1. The question, what would be the mean, the new mean? If this area changes, of course, if this area changes, if it's 0.05, then the mean has to move. So what is the new mean? Good. So we change it to Z. And of course, Z0 is a number here, positive, because this area is a small area, 5%. I have to deal with this area, which is 0.45. So I go to the table and search for 0.45. 0.45, yeah, is this one. Is this one. 1.645. So Z is 1.645. So Z0 is 1.645. And Z0 is X0, which is 6.14, minus mu, which is unknown, over sigma, which is 0.5, I believe. Yeah, sigma is 0.5. So multiply cross product and find the value of mu. So 0.5 times 1.645 would be 0.8225. So we have 6.14 minus mu equals to 0.8225. Take this here and take this here. So mu would be 6.14 minus 0.8225, and the answer would be 5.3175. So mu will be reduced from 5.5 to 5.3175. It has to go to the left. So the area to the right of 6.14 would be 0.05. A company that makes PSU tables and chairs has determined that the time it takes to make a complete set on their automated production line is normally distributed. So the time is the random variable X, the mean is given, the standard deviation is given. Given this information, what proportion? Proportion means probability. So what probability will be completed in 30 minutes? So what's the probability that X is less than or equal to 30? You just change it to Z and solve. That's easy. A randomly selected value from a normal distribution is found to be 2.1 standard deviations above its mean. What is the meaning of this? If the value is 2.1 standard deviations above the mean, this means that Z0 or Z0 of this value is 2.1. Or you can say Z, okay? 2.1 standard deviations above the mean. So Z, the standardized value of this value is 2.1. So what is the probability that a randomly selected value from this distribution will be greater than 2.1 standard deviations above the mean? So in fact, he is asking about X greater than something, but I can write it Z greater than 2.1 because he says 2.1 standard deviations above the mean. So Z0 is 2.1. So he's just asking about probability that Z is greater than 2.1, and this is easily found from the table. What is the probability that a randomly selected value from the distribution will be less than 2.1 standard deviations from the mean? So this is what we need to find. A random variable is normally distributed with a mean. This is the mean, standard deviation. If an observation is randomly selected, what value will be exceeded 10% of the time? Let us try to understand the meaning of the question. This is X, the random variable. Mu is 25. Okay. The question, if an observation is randomly selected, X0, what value will be exceeded? What value will be exceeded 10% of the time. So there is an x0, he is asking about x0, that will be exceeded 10% of the time. So there is an x0 here, and it will be exceeded 10% of the time. So the values will be more than x0 10% of the time. So in fact, he is asking about x0 in which probability of x greater than x0 is 0.1. So you change it to z and you find z0 and then x0 as usual. What value will be exceeded 85% of the time? So this is x, this is mu. Now he is asking about x0 that will be exceeded 85% of the time. So x0 in this case is a small number, is a number to the left of the mean. And you know that the probability of x greater than x0 is 0.85, or if you want to write it, x probability than x0 is 0.15. There is no problem. In fact, you will not use 0.85 or 0.15. You need to use this area, which is 0.5 minus 0.15, 0.35. So you'll use 0.35 to find z0, and then you find x0. Determine two values of which, let me solve this question because here z0 would be negative, okay? So I write probability that z is less than z0 is 0.15, and I search for 0.5 minus 0.15, which is 0.35. So I go to the table and look to 0.35 inside the table. 0.3, this is 0.3436, so I keep here 3485, 3508. Now this is 85 and this is 08. 08 is closer, so it is 1.04. 1.04. This is Z0. But remember, Z0 is to the left. So you take it negative. So negative 1.04. Now X0 would be Z0 times sigma, which is 5, plus the mean, which is 25. And the answer would be 19.8. So this graph is correct. Okay, and it must be correct, of course, because this is what we understand from the question. X0 is to the left of the mean, so it's 19.8. If you do not put minus here, you will get X0 to the right of the mean, and your answer will not be correct. Determine two values of which the smaller, so now I'm talking about two values. The smaller has 25% of the values below it. So this is X1 and 25 below it. And the larger, X2, has 25 of the values above it. So you have this information. Probability that X is less than X1 is 0.25. And probability that X is greater than X2 is 0.25. Change to Z and find X1 and X2. And notice that Z1 is negative, Z2 is positive. What value will 15% of the observations be below? So I'm searching for an X value in which 15% of the observations are below this value. So I know that probability that X less than X0 is 0.15. Okay, I will use 0.35, this area, to find Z0, which has to be negative in this case, and then I find X0. An expensive watch is powered by 3-volt lithium battery expected to last 3 years. All right. Suppose the life of the battery has a standard deviation 0.3 and is normally distributed. So the life is the random variable x. Determine the probability that the watch's battery will last longer than 3.5 years. So what is the probability that the life, which is x, will be longer than 3.5? Where is the mean? An expensive watch is powered by 3-volt lithium battery. Expected, this is the expected value or the mean to last 3 years. So in this question, the mean is 3 and the standard deviation is 0.3. You use this information and find this probability. Calculate the probability that the watch's battery will last more than 2.75. Change it to Z and find the value. Compute the length of life. So he's asking about x0 here, for which 10% of the watch's batteries last longer. Okay, this is x, the life, and 10% only 10% will last longer than this life, which is x0. So in fact, probability that x is greater than x0 is 0.1. Change it to z, use 0.4 to find z0, and then find x0. The last question, a maternity wear designer sells dresses and pants priced around 150 each for an average total sale of 1,200. So this is the average total sale, and this is each. Okay, the total sale, so that's x, has a normal distribution with a standard deviation of 350. So mu average total sale is 1,200. Standard deviation is 350. Calculate the probability that a randomly selected customer will have a total sale. So this is the total sale more than 1,500. You change it to Z and find the answer. Compute the probability that the total sale, which is X, will be within plus or minus 2 standard deviations of the mean total sales. So the difference between X, the total sale, and the mean total sales is within plus or minus 2. So within 2 standard deviations. So the difference between X and mu is less than or equal to 2. So if you want, you can write it X minus mu is between -2 and 2. Okay, so he needs this probability. He needs this probability. The probability that X minus mu is between 2 and -2. Now to change to Z, all what you need here is to divide X minus mu by sigma, because you have X minus mu. You need to divide only by sigma. So you divide by sigma here and here. So you have probability that -2 over sigma, sigma is known, sigma is 350. So -2 over 350 is a very small number. Okay, it's negative. If you use shift eng here twice, it would be -0.0057. Let me say 6. Okay, less than z, less than 2 over sigma. But here, yeah, pay attention, sorry. Plus or minus 2 standard deviations. It's not 2 standard deviations. You see, this number is very small. I realized that there is something wrong here. Yeah, but it's 2 standard deviations. So we have, in fact, 2 standard deviations here and here. So this is -2 sigma and this is 2 sigma. Now, if you divide by, so this is again 2 sigma, okay? So I have negative 2 sigma and 2 sigma. If you divide by sigma, you will get that Z is between negative 2 and 2. So this is the probability that Z is between negative 2 and 2. We know this probability, it's approximately 95%. If you want to find it now from the table, the actual percentage, so we need from 2 to negative 2, we need this probability. We can say that it is 2 times the probability that Z is between 0 and 2. So we go to 2, this is 2.4772. So we multiply 2 times 0.4772, and the answer would be 0.9544. So we know that it's approximately 95, but now this is the actual percentage, 95.44. Determine the median total sale. This is a nice question. The median total sale. Now he's talking about X, this is X, and he wants to find the median, okay? Let us say that the median is X0. The median is a value of X. What do we know about the median? Well, we know that the probability that X is less than X0 is 0.5. And the probability of X greater than X0 is 0.5. That's what we know. The median. 50% of the data lies to the right, 50% of the data lies to the left. So if you change it to Z, the probability is 0.5. If the probability to the right of Z0 is 0.5, this means that Z0 is actually 0, because we know that in Z, the mean is 0. To the right of 0, you have 0.5, and to the left of 0, you have 2.5. So if you look to 0.5 in the table, okay, you will find 0. For Z0 is 0. Now how to find X0? Well, Z0, X0 is Z0 times sigma plus mu, but Z0 is 0, so it's equal to mu. So X0 is in fact mu, the mean. So the median is the mean. And we know that. We know that in any normal distribution, the median and the mean and the mode are all equal. They are all here. So we know from the beginning, and if you want to answer this question immediately, that it is 1200, it would be correct. But I needed to also find it in another way. This is the end of section 6.1. We solved a lot of questions about this section. Hopefully, this will help you understanding normal distribution.